Flight Management Computer Polar Areas comprises the area north of 82 degrees north latitude or north of 70 degrees north latitude between 80 degrees and 130 degrees west longitudes, or south of 82 degrees south latitude, or south of 60 degrees south latitude between 120 degree and 160 degree east longitudes. Thus, as the fuel cools, it changes from a homogeneous liquid to a liquid containing a few hydrocarbon wax crystals to a slush of fuel and hydrocarbon crystals, and finally to a near solid block of hydrocarbon wax. Because the freezing point is defined as the temperature at which the last wax crystal melts, the freezing point of jet fuel is well above the temperature at which it completely solidifies. In consultation with airline dispatch and air traffic control, the flight crew decides on a plan of action. If possible, the action should include changing the flight plan to where warmer air can be expected. Another action is to descend to a lower altitude. The required descent would be within 3,000 to 5,000 feet of optimum altitude. In more severe cases, a descent to 25,000 feet might be required. If flying on a north-south track on a random route, you must plan to cross a whole degree of longitude every 5 degrees of latitude. It is important to use only standard ICAO terminology for effective communication with ATC. Non-standard terminology or jargon may create confusion. In most modern aircraft, the primary roll mode for polar operations should be lateral navigation, LNAV, which may be used with the heading reference switch in the norm position. Manual selection of a magnetic or true heading reference is accomplished by using the heading reference true norm switch. When the airplane is operating in a region where the IRS does not compute magnetic heading, the reference is automatically changed to true, independent of the position of the heading reference true norm switch. In the area of magnetic unreliability, VOR stations are referenced to true north. When the aircraft reference heading is selected to true, the information given by the VOR will be correct. However, if the reference heading is set to magnetic, the station will be displayed incorrectly. Due to the remote and harsh environment of the polar regions, operators transiting the area must have an approved specific passenger recovery plan for each diversion airport in place, actionable within 12 to 48 hours in the event of an unexpected en route diversion. The plan needs to address the full logistics of both passenger and crew handling, including provisions for their complete physiological, medical, and communication requirements, as well as plans for their transport from that airport onwards. The process of decision-making for diversion in the event of an emergency, in combination with the remote airfields as well as the hazardous weather, is very complex. The aircraft position in relation to the organized track system, terrain clearance, flight levels on adjoining routes, and possible desired tracks to an en route alternate should be taken into consideration to determine the direction of the first turn. There is no multilateral search and rescue agreement covering the entire Arctic region. The current SAR infrastructure is, while varying between regions, very limited. In general, there are shortages of critical SAR response assets, such as long-distance heavy-lift capacity aircraft and other equipment. Additionally, the usefulness of these assets is often limited by weather and other operating conditions, which may result in a long delay if assistance is required.